so we'll move to the last speaker of this session. It's Dariush Salami, and the title of the talk is Resiliency Evaluation Framework from 5G New Radio to 6G.
Thank you. So, hello. Before starting the presentation, I have a good and a bad news. Yet another talk, and it's going to be the last one. So it's up to you to decide which one was the good news and which one was the bad news. But yeah, thanks for the introduction. So I'm going to give a 15 minutes answer to your question, indeed, because it's exactly about how we can measure the sort of resiliency, I would say. So this work is done together with Akshay, my colleague who is here, and I assume many of you already have interacted with him, and also my line manager at Nokia, Mikko Usitalo. So basically, I'm going to start with why we need yet another sort of framework to measure resiliency. Then I will continue what does already exist in the literature or in the industry, I would say. And then I'll talk about the framework that we are proposing. It's just sort of like, it's not a perfect framework, I would say, in that regard, but it's more like a seed for thought that we can iterate over, and then we can come up with even better metrics. And finally, we will have the final notes and the feedback. So why do we need another evaluation framework? When we are looking at the more like a civilian networks that we have on the right side there, quite often what we are concerned with is the fact that if it's already working, and if it's fast, or maybe if it's green, I would say. But then when we talk about dual use and more like a defense context, it's slightly different, because there we are talking about a system that needs to survive in really sort of like harsh conditions when someone wants it dead, I would say, mainly. And then talking about the future, I would say 6G, we've already concluded that we need a lot of resiliency there, because there are going to be like intentional threats, from jamming to denial of service attacks, and even like a physical attacks, I would say. So because of these reasons, we started to think about how we can sort of create another framework for this spatial dual use case, where we need to deal with both civilian and also sort of defense-related conditions. So what do we have already in the literature? So there are three different aspects. One is 3GPP, which is, like so far, let's say, mainly focused on the civilian networks and the matrix that we already mentioned. For example, the block error rate, bit error rate, retransmission rate, and these type of KPIs. The second aspect is more like a research aspect, where, for example, there are different sort of like metrics such as jamming margin and so on and so forth, but they're not standardized, I would say. And this is something proprietary for sort of like different MNOs or vendors to implement. And then last but not the least, we have military, which is sort of like the metrics that are used completely in a military aspect rather than a civilian network. So here in this talk, we are trying to sort of combine these two perspectives of dual use, like the military side and then the civilian side. And also I think it's something that should be taken into account, that the resiliency should be sort of like a design principle rather than an afterthought. And I'm just iterating what other speakers said, so it's not something that I came up with, but it seems that it should be the case. So in this framework that we are introducing, we have, I would say, a two-layer approach. So in the first layer, we can think about metrics that help us to detect the attack. And those metrics, they are coming from two different, I would say, sides. One is the core network side, and then the other one is UE RAN side. I'll talk about those type of metrics that we can use to detect the attack itself or the disruption. I would say it's not necessarily the attack. It might be because of the natural disasters. And then in the second order metric, as Gürkan mentioned and other people already mentioned, we want to quantify sort of, for example, how we react to that disruption. did we do a good job, or we can improve, I would say. There was a really interesting example by Jaakko yesterday about this use case in Ukraine that they did a great job with recovering in a few days after the incident. And that was what I was thinking, that, I mean, it would be even better if we could say that, okay, they performed like 98% optimal, you know, to quantify that, how did they react to that disruption? And that's exactly what we are trying to do with these metrics. So moving on, talking about the first order matrix that can be used for sort of detecting the attack. From the UE RAN side, I would say, which can be extracted by processing IQ samples in L1 layer, I would say, we can, for example, think about jamming power, PJ, that we have here, or the ratio of the jammer to the UE power, PJ divided by S, which is basically SINR, and also probability of detection. So these, I mean, of course, this list can go on and on, so it's not like the sort of the golden rule, but just again, some thoughts that we have here. And then from the core network side, we can think about, for example, authentication retransmission rate per time, which in turn can sort of indicate the DOS attacks or denial of service attacks. But talking about the second order matrix, which we believe that they could be really nice indicators of resiliency, we can, for example, think about how did we get back from the incident to a baseline performance. For example, 95% of I would say, the optimal performance. So it can be sort of formulated like this: T-rec, which is the time of sort of like disruption, I would say, minus T0, which basically says that T-rec is the time of recovery, sorry. So which basically indicates that how long did it take us to recover from that disruption state. And obviously, the smaller the RL or recovery sort of latency, the better resiliency we have. Or the second metric that we can think about is how much extra power spectrum cost. I mean, it's up to us to decide, as Gürkan was saying. So we can define this cost factor, but anyways, how much extra cost we spend to recover from that disruption. And this can be formulated like this. So we have RFD and then minus R0 divided by R0. RFD is the sort of like the disruption cost. So how much did it cost for us to recover from that disruption? And R0 is the normal operating cost that we have there. So the lower RCF, the better in this case, obviously. Then we have this fairness sort of index that is sort of like, I would say, well studied in the field, but this Jane index that we can use to see if there were some premium users that they were hogging the whole sort of resource that we have. On the figure right-hand side, you can see that, for example, this blue figure shows a better, I would say, fairness score, because it shows that most of the resources that we had was distributed fairly among the UEs. But then there is a sort of small thing here that we need to take into account that, I mean, well, in general, it's good to be fair quite often, but imagine we are talking about the battlefield, and there we might have the case that we want to really focus on a few really critical UEs that we have there, and in that case, it might be the case that this red one is better, indeed. But anyways, it is still an indicator for resiliency, depending how you define it. And then we have how robust we are to jamming. This is well investigated in the military context. So it's basically what is the minimum sort of ISR that, what is the maximum ISR, or the interference to signal ratio that we can tolerate to guarantee a sort of like a baseline performance. And then last but not the least, how we can combine them all to come up with a single number that, just like we were talking with you, Rodoslav, that, I mean, can we come up with a number like 5 nines or something for resiliency as well instead of availability? So, I mean, we are proposing this, but I mean, it's very far from perfect, so we need to, you know, think about how we can make it even better. So to be able to understand a little bit better how these metrics can react in the real world situation. I've generated this picture by AI, by the way. So, I mean, if you see, I don't know, 6 fingers or 7 fingers there for the soldiers, don't mind. But yeah, so in a normal situation that we have here, which we call steady phase, as you can see, we have like a really good performance and everything is fine. Then at some point, imagine the space station is under attack and we have a drone attack or whatever. So we have the disruption. And again, I'm talking in military context, but it can be an earthquake, it can be a tsunami, whatever. So we have a disruption. Then what happens is that quite often this performance drops, like quite significantly. And then we start to sort of, I would say, counting the time to understand how long did it take for us to react to that event. So it's not to recover from that event, but just simply to react. For example, how long did it take for us to send the people, the personnel to recover from that attack? And that is sort of AI, I would say, index that we have, not the artificial intelligence, but the adaptability index. Then in the next phase, imagine we have already reacted, and it means that we have already sent the personnel to start recovering from that attack. Then we start another counter to sort of indicate that how long did it take for us from the start of the recovery to get back to a specific performance, I would say. And that can also go hand in hand with the RCF that we had, which was resiliency cost factor. So how much effort we invested and how long did it take for us to recover completely? Not completely, but to recover to some extent. And again, this is something that we can play with it. So the cost factor that I mentioned, you can define it whichever way that suits you. And then finally, we have again back to the steady phase where everything is fine and the whole network is recovered. So I think you've asked a lot of questions. Now I am asking a question. So according to the factors that we introduced, you think which one of these 3 networks or 3 engines that we have are more resilient? I mean, I have listed different type of factors there. Just as a hint, since we don't have a time, you just need to look into this integrated resilience score or IRS. So as you can, I mean, I assume that you can guess, but anyways, so we were talking about this integrated score, and in this specific example, for example, this engine C is sort of like more resilient, so to say. Why? Because we have higher IRS or integrated resiliency score. So this is what ideally we would want to have to be able to compare different systems in terms of resiliency. But I mean, I think there's way more things to be done before reaching that stage. But talking about the practical steps that need to be taken, again, Gürkan mentioned it really nicely that we might think like about all different types of KPIs, but when it comes to measurements, then we might not be able to measure them at all, right? So that is something that we need to take into account. For example, for this framework that we proposed, this G-Node B should be able to provide this L1 matrix, for example, this PI or SINR and probability of detection and so on and so forth. After that, in AMF, we should have a counter for authentication retransmission rate to be able to calculate AU that we had in this IRS. And then, I mean, obviously we need to run some tests in a controlled environment. It can be simulation whatsoever to be able to, yes, I'm done, almost. And then finally, we can have sort of like a dashboard, just like this one, to say that this system is 0.87, for example, resilient, I would say. So, well, the paper was short, so it's just 2 pages. But anyways, if you want to have full access to the paper, you can just scan that QR code, and we can interact after the talk as well. But just as final notes, so the classic KPIs might not capture fully the use cases that we have in dual use, I would say. That's why we proposed this. We had 2, like, multi-tier sort of framework. The first order to detect the attack or the disruption, and then the second order to measure how well or how good we reacted to that disruption. And then finally we introduced this integrated resiliency score to capture everything in one number. So thank you so much for bearing with me for 15 minutes or so. If you have any questions, feel free. Yes, please. Not hard ones, though. Thank you. Yes.
Yeah, thanks for the interesting talk. It's an important contribution. I actually have a lot of questions, but I'll focus on one short comment and 2 questions. So you asked us in this last slide which one is more resilient. I mean, that depends completely on how you choose your weighting factors. So that's one of the core problems in multi-objective decision making. Any of the 3 systems could have been the most resilient depending on your preferences. So yes, this is a core problem with defining these composite metrics. So that was my comment. You mentioned several times this absolute baseline. So you are proposing to evaluate after the fact with some very good measurable KPIs, very sensible, but you need to define some baseline, some optimum, which is much harder to do. So in the last slide, you had this 87% for the IRS. So I wonder how you get this baseline. And the second question is, don't you think the reconfiguration capabilities of the network should be taken into account? So you are focusing on a single network node, but your network should reconfigure and take alternative routes, and shouldn't that be somehow incorporated in measuring this? Thanks.
Yeah. Thank you so much for the great comments. I mean, 100% agreed. So, well, I mean, obviously the way that you define the W's or the weight factors, it influences everything, and that's 100% true. And in the figure that I had there, I assume that we have the same sort of weight factor there, which is a very simple and naive assumption. But as I mentioned, what we were trying to do was that to introduce I mean, I would say like a very rough version of the framework, how it could be, I would say, just as a seed for thought. Otherwise, I mean, it's far from perfect to be deployed in a real-world scenario, as you were mentioning. And then back to the second question, which was the first question, which was about this baseline performance. So, I mean, that's true. Like, again, I assume that depends on the case. For example, if you have a G-node be in the middle of the city, like in Barcelona, then you expect some performance from that. And then if you have it in the battlefield, you expect something completely different. So that 100% depends, I mean, on the use case. And then, I mean, we don't have any solutions for that, how we can compare those two, in a sense. But yeah, it was mainly, I was just thinking that it's sort of a single point that we are looking into. So we are looking into the performance of just this cell, for example, to be able to sort of come up with some numbers. And then the last point, the reconfigurability, that's also very valid. I mean, I don't have anything to add to that because we're not addressing that with this framework, but 100% true.
Excuse me, I think we can take the questions over.
Add on to what Dariush said to just respond to the question, but maybe I can.
Yeah, you can take it over the coffee break.
Thank you.
Sorry. Yes. Thanks, Dariush.